The next one is Magnify or Minify. The size, color, smell, and movement can be changed in various ways. In experimentation, you can magnify and minify time, frequency, strength, altitude, length, thickness, and value. To magnify them several times or even thousands of times, you can make it bigger or minify them into a huge percent. Then here's what you are working on. You can magnify them or you can minify them. So one simple example of magnification is a walk-through maze or hedge maze. A walk-through maze is built by magnifying a maze puzzle hundreds of times. The people enter the maze, finding a way out, or simply enjoying taking a walk. On the other hand, Minification may change the ways in which things are used. For instance, the Sony Walkman portable cassette players had a huge effect on the lifestyles of young people in the 1980s. So they were able to carry their favorite music recordings wherever they went. In the previous lecture, I told you about the solid phase synthesis of DNA. The magnification of one component permits the quick purification of the reaction product. The magnification or minification approach may allow you to conceive unconventional ideas. So next one is put to other uses. So you can consider the new applications without making any changes, or by making partial modifications or improvements. So for example, can you use DNA for something other than genetic inheritance? To consider these two questions. What are the characteristics of DNA? Then information, is one, or helix, or base pairing, or DNA is actually acid. There are many characteristics of DNA. In what fields can we make use of these characteristics? So this process may allow you to conceive new ideas. I'll give you one example, which has actually been performed by Professor Higuchi at Nagoya City University. He focused on the property of DNA as information and engaged in the joint research program with Nissan Motor Company. So here is his idea. Chemically synthesize DNA over a certain length. Then mix small amount of DNA into the paint, in the automobile paint. Right? So when the DNA with 20 bases is synthesized, more than 60 billion sequences can be created, which is enough for identifying a vehicle. If there is a hit and run accident, so you paint the car with this paint. This guy has a DNA in there. So then if there is a hit and run accident, the DNA from a small amount of paint is left at the scene. At the scene of the accident. So it can be amplified using PCR. Then you get a larger amount of the DNA in the paint. You can amplify the DNA in the paint. Then sequence it. Then you should be able to identify the vehicle. Then I thought this was a great idea when I was told about it by Professor Higuchi. But unfortunately, that technology has not been commercialized. The problem is durability. The vehicles are exposed to sunlight, especially in summertime. The DNA is considered to be stable, but DNA is weak with UV irradiation. The stabilizing DNA in paint could pave the way to commercialization of this idea in the future. But this idea applies to put to other uses in the scamper technique. So DNA is information, and information can be used in vehicle identification. So that was a nice idea.